In the world of heating, ventilation, and air conditioning, or HVAC, understanding the ins and outs of heat load calculations is paramount. You see, these calculations are much more than mere numbers on a page. They represent the very foundation upon which a comfortable and efficient HVAC system is built. Heat load calculations determine the cooling capacity needed for a space, whether it's a cozy living room or a bustling corporate office. They account for everything from the size and orientation of a room to the type and amount of insulation used. Without accurate calculations, an HVAC system might be forced to work harder than necessary, leading to inefficiency and increased costs. It's akin to trying to cool a room with an open window. All the cool air just slips away. So the next time you see a heat load calculation, remember, it's not just a number. It's a crucial part of creating a comfortable and cost-effective environment. Now that we know why heat load calculations are so important, let's dive into how to actually perform these calculations. Before we start crunching numbers, it's crucial to understand the basics of heat load calculations. So, what is heat load? Simply put, it's the amount of heat that needs to be removed or added by the HVAC system to maintain a desired room temperature. It's typically measured in British thermal units, or BTUs. Now let's talk about the three types of heat. First off, we have sensible heat, which is heat that can be felt and measured. Next is latent heat, which is heat absorbed or released during phase changes like evaporation. Lastly, there's total heat, which is the sum of both sensible and latent heat. Various factors affect the heat load. The size of the room plays a major role, as does the number of occupants. Appliances used in the room also contribute to the heat load, as each emits a certain amount of heat. With the basics covered, it's time to get into the nitty-gritty of heat load calculations. Now, we start the process of calculating heat load. The first step in this process is to measure the size of the room. This includes the length, width, and height. It's crucial to be precise with your measurements because even small discrepancies can significantly affect your heat load calculations. Once you've measured the room, you'll need to calculate the heat generated by occupants and appliances. This is our second step. Now, how do we do that? Well, every human and piece of equipment in the room generates a certain amount of heat, measured in British thermal units, or BTUs. For instance, an adult at rest generates about 400 BTUs per hour, while a computer might generate around 300 BTUs per hour. You'll need to add up all these heat sources to get the total heat generated within the room. Now we've reached the third step of our heat load calculation, adding all the heat sources together. This includes the heat from occupants and appliances, but also from other sources such as lighting and sun exposure. The total of all these sources gives us the total heat load of the room. Remember, this is a simplified explanation. In reality, you'd also account for factors like insulation, windows, and the direction the room faces. But for now, understanding these basic steps will give you a solid start. Before we move on to summarizing this process, how about hitting that subscribe button? We have a lot more HVAC tips and tutorials coming your way. Staying updated with our channel means you'll always have the knowledge you need to tackle HVAC challenges. And there you have it, the total heat load of your space. But how do we summarize this process? Stay tuned to find out. Let's summarize the steps for calculating heat load. It all starts with measuring the room. You'll need to know the width, length, and height to determine the volume of the space where the HVAC system will operate. Next, we factor in the heat generated by occupants and appliances. Each person and device in the room contributes to the total heat load that the HVAC system will need to handle. Once we've gathered all this data, it's time to add everything together. This sum gives us the total heat load. But here's the thing, the accuracy of these calculations is paramount. Any errors can result in a less efficient HVAC system, leading to higher energy costs and a less comfortable environment. So take your time, double-check your measurements and your math. Remember, understanding and accurately calculating heat load is your first step towards an efficient and effective HVAC system.